So I'm going to roll straight into introducing Stacy. Stacy Morse is going to be talking about two things that I love, which is CircuitPython. I like MicroPython, but each their own, and also photography. So we're going to hear about how we can use those two things together. So as soon as we've got it mic'd up, if you could please put your hands together for Stacy.
Okay, I think I've unmuted myself. All right, so this is my second time at PyCon Australia, which is awesome. I'm a programmer, artist, maker, and some other stuff. It's all my contact information. I tweet often, but not so much that it's annoying. I'm definitely going to have all of my slides available probably by the end of the day because this is an image-heavy talk, and images and art don't really translate super, super well when they're being shown up on a screen. So feel free to tweet at me or ask me questions or find me after my talk, and I would love to talk about any of this stuff with you. So this is actually a love story, and it's how I fell in love with Python, and hopefully it's a very inspiring story to other people because I think I can solve a few problems aside from CircuitPython problems. So I absolutely love Python, and that's no secret. I tweet about it a lot, and I love the community around it, and I showed this talk in a very rough form to my local Python user group, and they helped me a lot, and they said, Stacy, you don't have any art at the beginning of your talk. So I'm like, okay, I'll stick up a whole bunch of art. So right now I'm just going to go through a bunch of my art. My artist statement is online, and I will tweet that out as well. An artist statement is kind of like your description of what it is that you do with your art. I seem to take that for granted that a lot of programmer type people don't know a lot about art. Some do. But so here are some of my images. I like to focus on macro photography. So you will often find me crawling around on the ground in the woods and people coming upon me horrified and scared and like, are you okay? I'm like, no, really, I'm just taking pictures. It's fine. So I also take some really personal types of pictures. Some of these images that you'll see, like this one, my family's house burned down shortly after my father passed away, and I broke into the house legally. It's a gray area. So I went in to take photos because that's what an artist does. They constantly take images, but everything I do is pretty much macro photography. So I like to find just about anything that you can find and take a really close look. Some things aren't like this, but I like to add, tech elements and things that we discard and like just leave behind. And I also like to take photos when I come here to Australia. So that's one of the ones from the gardens in Melbourne. Another one from my family's home. But yeah, so this is what I do for art. This is what I went to art school for. And I really love what I do art-wise. So artists typically don't have a lot of money. Art doesn't pay very well. People often expect you to do it for free. And that's cool and all. I do give a lot of my images away as gifts. But, I'm also a web developer. I program in Python, and I'm a very technical person. So why am I here, and why did I do this? Well, LED light arrays, when I first started this project, were really, really, really expensive. I mean, extremely expensive. I'm not sure if other people have ever looked into photo light arrays. They were very simple, and they were very expensive, and they did not meet any of the needs that I personally had as a photographer. So that's me as a kid on my birthday when I was 9. And I got a microscope, so I've obviously always been very obsessed with looking at things very close up. And I was I was very involved in STEM as a kid, loved physics, loved engineering solutions to problems. And I can make a serious solar oven out of a box, a spoon, some sand, and some black spray paint. So, I love STEM, but I'm also an artist. So I went from STEM in grade school to art in college, which was one of those things that a lot of people are like, what? I don't understand it, but art is really process-driven. There's a lot of process in photography. If you've ever taken a photo class, you'll understand how much math and how much science and chemistry and everything that is involved in taking a really good photograph. A lot of things that apply to programming apply to art. So the path to me didn't feel odd, it was natural, but for a lot of other people, they scratch their head and they're like, how are you possibly a programmer? And well, it kind of all started back as an art director for an ISP, and I did some coding there, and then I got away from it for a while, and I went on to actually doing some more art. And I would go back and forth over the course of my life between doing some sort of tech job, some sort of art job. And I was very resistant to learning more coding, and I'm not really sure why. I think it was just I had so much stuff on my plate at the time, I didn't want to bog myself down, and I thought, programming is going to be so hard. I mean, it's not the easiest thing in the world. There is a level of difficulty to it, but I didn't have any motivation to learn. Like, there was really no reason for me to learn how to program. So I had a conversation, and PP actually stands for Python Programmer. So this was the actual conversation that we had that got me interested in learning how to program. And I feel that that person really opened up, a really new world for me, and it was really, really awesome. So I'm going to stray really slightly from my talk just for a second, because I see a lot of people talking about diversity in tech, and this isn't going to be like this is just a quick tale. I was an artist, a technical person that knew how Python worked, knew that I could solve my problem. They introduced me to this, and they said, here's a bunch of links, here's a bunch of stuff to read. You can solve your problem. You can, start learning how to program. And I really, aside from HTML and CSS, I didn't have much understanding way back then of, programming itself. So if we as programmers can talk to people that are not technical and ask them what sorts of issues they're having and help them solve those problems, we can totally bring more diversity into tech, because there are people that never thought about it before. So anyway, back onto my problem, because I had an actual problem. And my problem was that I make macro photos, and I needed a better way to light them, which was not super expensive. One of those LED arrays that I was talking about at the time of the project when it first started, they were about $400 for a very small LED array that would just turn on and off. And that was not going to work for me. So after I pondered all these things, that I could not generate light beams out of my fingertips or eyes, and how disappointing that was, I sat down and I started to learn how to program in MicroPython. That's how the project started. So to talk about photography real quick and why it's important to have light, macro photography itself is an extreme close-up photography. The subject is very small, yet the photograph appears really large. And the reproduction ratio is the ratio of the subject and the size of the sensor or film. It's the plane to the actual subject size. So the lens that I currently use is a 100 millimeter, I shouldn't say the brand, it's a 100 millimeter lens, and it has a 1-to-1 ratio. So the focal length and a lot of the things that you'll see when I start showing them is going to be an f. A lot of photographers will refer to that as an f-stop. So for an example, a 2.8 f-stop is inversely proportional to the field of view. I have all of these terms up on a blog post so that if anybody wants to go through them, and I know this is a lot of information, and it's a lot of photo information. But if you look at a photograph and you see some things in focus, and then things in front of it are out of focus, and things and behind it are not in focus, it's because of the curve of the mirror or the curve of the lens, and how much light gets to the particular area and how much light at that one point gets to that particular area and how much of that is going to be in focus because of it. It's kind of like when you squint your eyes, and supposedly things are more clear when you squint your eyes, so the smaller the aperture, the more things are going to be in focus, because that's how it was explained to me in art school. I didn't really think that was a good way to explain it, but you know. This is where the connection to math and being very technical comes into art. I mean, photography is really, really technical, especially if you've ever tried to actually take apart one of those DSLRs. Yeah, we have to do our own math, a lot of math. There's a lot of math involved in photography. I would highly recommend anybody that uses a DSLR to get yourself a light meter, and I can show you my light meter because I brought it with me, and take it off of automatic and use it on manual. Learn how to use your camera on manual and take light readings. It will give you a lot more freedom, and you will feel way more satisfied with how much control you have over your camera. And I could get into all that, but that's probably like another 45-minute talk. So we'll move on to light. The reason why this is so important, the reason why I had to make what I made is because light is really important to macro photography. A true macro lens, you can bring it like right upon your subject, like within millimeters, and it will be in focus. But you can't light something that is that close to the subject. It's just not possible. So camera designers, camera engineers, they came up with lenses that are not true macro. They're actually called telephoto macro lenses, and that's what this is. And you can see by the length of the lens that the light has to travel a really far distance. And it doesn't seem at first like it's a lot, but typically telephoto macro lenses like this, they don't have a smaller f-stop than most lenses do because of the light issues needing to get the light to the sensor or to the film. So one of the things that you have to do when you're doing macro photography is you have to use a tripod because you'll get camera shakes because the light is going to take a lot longer to hit your sensor or your film. I do still shoot in film sometimes. So that is a lot of information. So I'm just going to take a second here. Always got to put up a picture of my dog. So that's a lot of like what happens on the photo end of taking macro photos. And if you want to talk more about it at some point later, find me. We can ramble all day. So now that I knew what my problem was, I had to solve it. And I needed a light source, but how was I going to exactly do it? So I started gathering my own requirements. I needed to be able to turn it on and off. It needed to be mobile, so I had to have it battery powered. I needed to be able to control the brightness. I would like to be able to control the color because bringing gels out into the woods is not a lot of fun. A gel is just a piece of plastic, if you will, that's colored that you put over in front of a light, and you can change the color composition of your photography without bringing it into Photoshop. And I didn't want to have to do that. And I also wanted to be able to select the number of LEDs that I was going to light so that I could really fine-tune how much light I was going to use. I know, another dog. Any excuse for a good dog picture. Seriously, I was told I could solve my problem, and now that I knew what my problem was, I needed more of a guidance from my technical encourager, the Python programmer that I previously mentioned. So they sent me more links about more things, and this is how I started figuring out exactly what I needed to do. I was going to need a microcontroller, LEDs, and at the point when I first started this, I was going to use a rotary encoder and buttons. And then as I rewrote everything within a very short amount of time, I found this. And it changed my life. It's just a tiny little IR remote, and I could map every single thing that I needed to do to this little remote. So I no longer had to have buttons or a rotary encoder, which the code for it was fine. It worked really well. I just could simplify my entire life with that. So we'll look at the parts of what it is that I built. And so I decided to go with NeoPixels because they are RGBW, and that's really important to photography, whereas This will give me a true white, and you have a few options with this sort of layout with the RGBW. They come in, different types of white light, and some people would want to use those other types of white light. And I mostly use white light in my photography. It's very rare that I use the colors, but I like to be able to have them there if I wanted to. So I started building this, and I started it with the Circuit Playground because it was really easy to redo everything very quickly, and it just worked with CircuitPython. So I did the entire project without my NeoPixels on the separate Joule, and I did it all just rough coding out on a Circuit Playground. And I'm like, awesome, this works really well, but I need a little more fine-tuned so I can control it a little bit more. So I moved over to a Feather M4 Express, which was awesome because I kept running into memory issues with the initial board that I was using. So this alleviated any of those extra issues that I had. I had no crashes after I switched over to the Feather M4 Express. So the prototyping with the Circuit Playground was great. It did everything that I needed to do and more. And then switching it over was, as simple as just changing a few aspects of the board that I was using. And then I decided, because I was using a remote now, I had to integrate an IR receiver into it. And the code for that is so much fun. I seriously gathered up all of the remotes in my house and was playing with them to read what the IR encoding was on all of them with the IR, with the test code for it. I probably spent way more time on that than I should have. And then instead of going straight and doing it all over again in MicroPython, I figured I'm going to do it in CircuitPython. And because CircuitPython is super, super, introduction easy, the documentation's there, there's a lot of people that answer your questions, and it's at a lower cost point. And that's one of those things that I really like to think about when I want to share a project like this, is because I know what it's like to be an artist, and I know what it's like to be absolutely broke. And giving someone else the ability to build this for a fraction of what they would spend going through a large retailer that sells photo equipment for something that might not even be exactly what they need, I felt this would be a great way to give back to the Python and the art community. So I decided to do it in CircuitPython, and that way maybe encourage a few people to, learn this code in Python and add some stuff to my code if they felt like it. I tweeted out before my talk the actual code if you want to look at it. So when I got all the list of all my requirements and everything, what I had, what I needed it to do, I just started going through and writing, the different functions to control each aspect of it. And this is part of the code just to control the brightness going up and down. I mean, it's really, really simple. It's super, super simple, to control turning an LED, making it brighter, making it less bright. And I did it in an increment that I could record in my journal as I'm taking photographs to know exactly how bright my photos are going to be, how much light I'm giving it, because I like to collect a lot of data, hence why the transition to becoming a programmer was so easy for me. So I had to do a lot of photo tests, and this is the setup of my camera as I was doing those tests. And the test that I needed to do was to show what natural light was versus my brightness. This is a naturally lit photo. This is ambient light. This is no LEDs, none of that. So this is what it would look like if you were taking a photo inside your house with, I believe there were LED lights in the room, as the main lighting of the room, but this is ambient light. So when you turn off all the lights and you just use the light source, this is what you would get. And so this is at f16, the f-stop that I talked about, and that's a 15-second exposure, which is why you need a tripod, because there's no way you're going to hold a camera still for 15 seconds. And all those little dots indicate that each one of those is an LED that is on, and that's the minimal brightness. So this photo was taken at these parameters with my rig with all of the LEDs on, with the brightness at the minimum that they turn on at, like the minimum factory turn on, the brightness that they're on when you initially turn them on. So I'm going to show you a bunch of the same photo with different settings. And you can kind of see how each one deviates. So they all have the same amount of LEDs on them. They just have different settings, because what happens is you'll see certain parts of the photograph going out of focus. You can kind of see it in the green part behind the flowers themselves as I keep going further and further down. And that's what's important about being able to light a photograph, is to be able to have the control to change your depth of field. Because this is a completely different look than that. I mean, that could mean, as you're making art, the impact that this would have in a different subject matter would be much stronger than something where everything in the image is in focus. It gives an appearance of being flat. So this gives more depth. So I went through and I did all these, a whole bunch of these, and I got to the point where I'm like, okay, I'm going to kick it up to 20 brightness, and I'm just going to use all the LEDs as bright as I can possibly make them and see how fast I can get the exposure. So I did 2 of those, and they're similar to the other photographs, except now I don't have to have the exposure last as long. So I made this rig. It works really well. It's not all that great to bring out into the woods because it's completely open. And I'm not going to turn it on because I just thought about the fact that I might blind someone, and that's not cool. But what I want to do is I bought a hot shoe control that I'm going to cannibalize and use it to transmit data from my camera to my phone at some point. And I need to 3D print a container for it, because this needs something to be held in. And it needs a watertight box, because I often drop my stuff in water when I'm hiking. But those are the things I'd like to add. There's also some programming aspects to the functionality of this that I would like to add. But as this is right now, this is way more functional as a light than anything that anybody could buy. And it solved a big problem that I had as a photographer, just with some code. And you can see the code. I do have it up on my GitHub account. I think we're close to out of time. Yeah. But thank you for everyone for coming. I always love coming back here. So, yeah. I don't know if we have time for questions. It's getting close.
Yeah, look, first of all, thanks Stacy for that. And I think the general conference started a couple minutes late, so we've probably got time for a couple of questions if anyone's got any. Yeah.
G'day, brilliant speech. Thank you very much. So on your current implementation, do you just turn it on like a normal flashlight and then snap it once you're ready?
I do. I wanted to add videos of me actually using it, but I didn't want to make everything complicated. So I will be more than willing to demo it outside of here, because I don't want to be shining it in anyone's eyes. And I was really worried about turning it on up here, so I will absolutely demo it out in the hall. I did bring a full charge battery pack, and fingers crossed live, things. I will absolutely be able to show you how it works.
Awesome. Love to see it. Cheers.
Anyone else?
I'm kind of curious about this hot shoe adapter you've got. What sort of cool things can you do with that? Like, you said connecting up to your phone?
Well, I'm going to have to do a lot of hacking to get this to work. So I bought the cheapest hot shoe I could. The hot shoe is the top part of your camera with that little bevel where you would put a flash. And a hot shoe typically controls studio flash or other types of things like that. So I figured I could probably use that communication in some way with some doing to get the information that I need off my camera, the XF data, so that I can, at the same time, the XF data, I can also figure out what data I'm using for how many lights I have going, what color and all that, and write it all together into a file. So that's my next big project. I'm sure at some point I will release it, but yeah, that's what I'm working on next.
Time for one more? Yeah.
Is there anything that you see that you could do with this that you wouldn't be able to do with traditional flash photography kits?
Absolutely. So flash photography, first off, a lot of flashes aren't LED based. It's cost prohibitive, and it's just one of those things that a lot of people have not been able to nail down the rate of. LEDs blink really fast all the time. So I don't know if you've ever taken a picture of a television. If you don't get it to sync right, an old tube television. If you don't get it to sync right, you'll see lines because it's writing across the screen at a certain rate. So if you don't get it to sync right, it has that problem. Well, LEDs blink. And if you don't get them to blink in coordination with what you're doing photo-wise, if you're taking faster photos, you might not be able to light your photo. You might completely miss it. So not many people have taken on trying to make an LED flash for a camera. And this I can actually set up, turn it on, see where I need to focus, get everything focused, turn it back off to conserve battery power, do anything else that I need to do, and then turn it back on and focus a very specific part with the light that I have, whereas most other LED arrays are just big panels, and they just kind of want you to like stick it there and like light the entire thing. I don't do that with my photography. I like to light a very small element of it. I left my entire hard drive of all my favorite images at home, so I couldn't show. I have a lot of really beautiful images of fungi and mushrooms where I kind of lay up underneath logs and I light the gills underneath, and that's all I want lit. I don't want anything else lit. So with what I've made, I can do that, whereas what they provided, I absolutely could never do that.
All right, folks, we're going to have to wrap up there. If you could put your hands together again, please, for Stacy.
Thank you.
Before you all go, the three people who ask questions, can you please raise your hands again? Right, we've